Java EE Beginner Introduction. In today's business world, applications need to access data, apply business logic, and presentation layers, be mobile, use geolocalization, and communicate with external systems and online services. That's what companies are trying to achieve while minimizing costs using standard and robust technology that can handle heavy loads. If that is your case, you have the right book in your hand. Java Enterprise Edition appeared at the end of the 1990s and brought to the Java language a robust software platform for enterprise development. Challenged at each new version, badly understood or misused, over-engineered, and competing with open source framework. J2EE was seen as heavyweight technology. Java EE benefits from these criticisms to improve and today focus on simplicity. If you are part of the group of people who still think that AGB are bad, AGB are evil, read this book and you will change your mind. AGB Enterprise Java Beans are great, as in the entire Java EE 7 technology stack. If on the contrary you are a Java EE adopter, you will see in this book how the platform has found equilibrium through its ease of development and easy component model. If you are a beginner in Java EE, this is also the right book. It covers the most important specification in a very understandable manner and is illustrated with a lot of code and diagrams to make it easier to follow. Open standards are collectively one of the main strengths of Java EE. More than ever, an application written with GPA, CDI, bean validation, AGB, GSF, GMS, swap web services, or RESTful web services is portable across application server. Open source is another of Java EE strength. As you will see in this book, most of the Java EE 7 reference implementation use open source licensing as Glassfish, Eclipse Link, Welt, Hibernate Validator, Mojara, OpenMQ, Metro, and Jersey. This book explores the innovation of this new version and examines the various specifications and how to assemble them to develop applications. Java EE 7 consists of nearly 30 specifications and is an important milestone for the enterprise layer. CDI 1.1, bean validation 1.1, AGB 3.2, GPA 2.1. For the web tier, Servlet 3.1, GSF 2.2, Expression Language 3.0, and for interoperability, GIXVS 2.3 and GIXRS 2.0. This book covers a broad part of the Java EE 7 specification and uses the GTK 1.7 and some well-known design patterns as well as the Glassfish application server, the Derby database, JUnit, and Maven. It is illustrated abundantly with UML diagrams, Java code, and screenshots. How the book is structured. This book concentrates on the most important Java EE specification and highlights the new future of this release. The structure of the book follows the architectural layering of an application. Chapter 1 briefly presents Java EE 7 essential and appendix highlighted the tools used throughout the book and how to install them, JDK, Maven, JUnit, Derby, and Glassfish. In the first chapter, I explained the common concern discussed throughout the book. Chapter 2 described context and dependency injection 1.1 and Chapter 3 looks at bean validation 1.1. Chapter 4 through Chapter 6 describe the persistent tier and focus on GPA 2.1. After a general overview with some hands-on example in Chapter 4, Chapter 5 dives into object relational mapping, mapping attribute relationship, and inheritance, while Chapter 6 shows you how to manage and query entities, their life cycle, callback method, and listeners. To develop a transactional business logic layer with Java EE7, you can naturally use AGB. Chapter 7 through Chapter 9 describe this process. After an overview of the specification and its history, Chapter 7 concentrates on session bean and their programming model. Chapter 8 focuses on the life cycle of AGBs, the timer service, and how to handle authorization. Chapter 9 explains transaction and how GTA 1.2 brings transaction to AGB as well as CDI beans. In Chapter 10 and 11, you will learn how to develop a presentation layer with GSF 2.2. After an overview of the specification, Chapter 10 focuses on how to build a web page with GSF and facelet component. Chapter 11 shows you how to interact with NAGB backend with CDI backend beans and navigate through pages. Finally, the last chapter presents different ways to interoperate with other systems. Chapter 12 explains how to process XML using GIXB and GIXP. And JSON. Chapter 13 shows you how to exchange asynchronous message with the new GMS 2.0 and message-driven beans. Chapter 14 focuses on swap web services, while Chapter 15 covers RESTful web services with the new GIXRS 2.0. Chapter 1. Java EE7 at a glance. Enterprises today live in a globally competitive world. They need applications to fulfill their business needs, which are getting more and more complex. In this age of globalization, companies are distributed over continents. They do business 24 hours, 7 days over the internet and across different countries, have several data centers and internationalized systems which have to deal with different currency and time zones. All that while reducing their costs, lowering the response time of their services, storing business data on reliable and safe storage, and offering several mobile and web interfaces to their customer, employees, and suppliers. Most companies have to combine these complex challenges with their existing enterprise information system, ICE, at the same time developing business-to-business application to communicate with partners or business-to-customer system using mobile and geolocalized application. It is also not rare for company to have to coordinate in-house data stored in different locations, processed by multiple programming languages, and routed through different protocols. And of course, it has to do this without losing money, which means preventing system crashes and buying highly available, scalable, and secure. Enterprise applications have to face change and complexity and be robust. That's precisely why Java Enterprise Java EE was created. The first version of Java EE, originally known as G2EE, focused on the concern that companies were facing back in the 1999 distributed component. Since then, software applications have had to adapt to new technical solutions like SWAP or RESTful web services. The Java EE platform has evolved and to respond to these technical needs by providing various ways of working through standard specifications. Throughout the years, Java EE has changed and became richer, simpler, easier to use, more portable, and more integrated. In this chapter, I will give you an overview of Java EE and after an introduction to its internal architecture, component, and services, I will cover what's new in Java EE 7. Understanding Java EE. When you want to handle a collection of objects, you don't start by developing your own hash table. You use the collection API application programming interface. Similarly, if you need a simple web application or a transactional, secure, interoperable, and distributed application, you don't want to develop all the low-level APIs. You use the Enterprise Edition of Java, just as Java Standard Edition Java SE provides an API to handle collection. Java EE provides a standard way to handle transaction with Java's Transaction API GTA. Messaging with Java Message Service GMS, or persistence with Java Persistent API GPA. Java EE is a set of specifications intended for enterprise applications. It can be seen as an extension of Java SE to facilitate the development of distributed, robust, powerful, and highly available applications. Java EE 7 is an important milestone. Not only does it follow in the footsteps of Java EE 6 by focusing on an easier development model, but it also adds new specifications as well as adding new functionality to existing ones. Moreover, context and dependency injection CDI is becoming the integration point between all these new specifications. The release of Java EE 7 coincides closely with the 13th anniversary of the enterprise platform. It combines the advantage of the Java language with experience gained over the last 13 years. Java EE profits from the dynamism of open source community as well as the rigor of the GCP Java Community Process standardization process. Today, Java EE is a well-documented platform with experienced developer, a large community, many deployed applications running on company servers. Java EE is a suite of API that can be used to build a standard component-based multi-tier application. These components are deployed in a different container offering a series of services. Architecture. Java EE is a set of specifications implemented by different containers. Containers are Java EE runtime environment that provide certain services to the component they host, such as lifecycle management, dependency injection, concurrency, and so on. These components use a well-defined contract to communicate with the Java EE infrastructure and with the other component. They need to be packaged in a standard way following defined directory structure that can be compressed into archive file before being deployed. Java EE is a superset of the Java SE platform, which means Java SE API can be used by any Java EE component. Figure 1.1 shows the logical relationship between the containers. The arrows represent the protocol used by one container to access another. For example, the web container host servlet, which can access Egp through RMIIIOP. Component. The Java EE runtime environment defines 4 types of components that an implementation must support. Applet are GUI, graphic user interface applications that are executed in a web browser. They use the rich Swing API to provide powerful user interface. Applications are programs that are executed on a client. They are typically GUIs or batch processing programs that have access to all the facility of the Java EE middle tier. Web application made of servlets, filters, web event listeners, GSP and GSF pages are executed in a web container and respond to HTTP requests from web client. Servlet also supports SWAP and RESTful web services endpoint. Web application can also contain Egp Lite. More on that in Chapter 7. Enterprise application made of enterprise Java beans, Java message service, Java transaction API, asynchronous calls, timer service, RMIIIOP are executed in an Egp container. EGBs are container managed component for processing transactional business logic. They can be accessed locally and remotely through RMI, remote method invocation, or HTTP for SWAP and RESTful web services. Containers. The Java EE infrastructure is partitioned into logical domain called containers, see figure 1.1. Each container has a specific role, support a set of APIs, and offer a service to component security, database access, transaction handling, naming directory, resource injection. Containers hide technical complexity and enhance portability. Depending on the kind of application you want to build, you will have to understand the capability and constraint of each container in order to use one or more. For example, if you need to develop a web application, you will develop a GSF tier with an Egp Lite tier and deploy them into web container. But if you want a web application to invoke a business tier remotely and use messaging and asynchronous calls, you will need both the web and Egp containers. Java EE has 4 different containers. Applet containers are provided by most web browser to execute applet component. When you develop applet, you can concentrate on the visual aspect of the application, while the container gives you a secure environment. The applet container uses a sandbox security model where code executed in the sandbox is not allowed to play outside the sandbox. This means that the container prevents any code downloaded to your local computer from accessing local system resources such as processes or files. The application client container HCC includes a set of Java classes, libraries, and other files required to bring injection, security management, and naming service to Java SE application, Swing, batch processing, or just a class with the main method. The HCC communicates with the Egp container using RMIIIOP and the web container with HTTP for web services. The web container provides the underlying service for managing and executing web components, servlet, Egp Lite, GSP, filters, listener, GSF page, and web services. It is responsible for instantiating, initializing, and invoking servlet and supporting the HTTP and HTTP protocols. It is a container used to feed a web page to client browser. The Egp container is responsible for managing the execution of the enterprise beans, session beans, and message-driven beans containing the business logic tier of your Java EE application. It creates a new instance of Egp, manages their lifecycle, and provides services such as transaction, security, concurrency, distribution, naming service, or the possibility to be invoked asynchronously. Services. Containers provide underlying services to their deployed component. As a developer, containers allow you to concentrate on implementing business logic rather than solving technical problems faced in enterprise applications. Figure 1.2 shows you the service provided by each container. For example, web and Egp container provide connector to access IaaS, Enterprise Information System, but not the applet container or the HCC. Java EE offers the following services. Java Transaction API. These services offer a transaction demarcation API used by the container and the application. It also provides an interface between the transaction manager and the resource manager at the service provider interface SPI level. Java Persistence API, standard API for Object Relational Mapping (ORM), with its Java Persistent Query Language (GPQL), you can query objects stored in the underlying database. Validation. Bean validation provides the class and method level constraint declaration and validation facilities. Java Message Service. This allows a component to communicate asynchronously through messages. It supports really point-to-point P2P messaging as well as the publish, subscribe, pub/sub model. Java Naming and Directory Interface. This API included in Java SE is used to access naming and directory systems. Your application uses it to associate, bind the names to object and then to find these object lookup in directory. You can look up data source, GMS factories, EGBs, and other resources omnipresent in your code until G2E 1.4. GNDI, Java Naming and Directory Interface, is used in a more transparent way through injection. Java Mail. Many applications require the ability to send emails, which can be implemented through the use of Java Mail API. Java Beans Activation Framework. The GIF API included in Java SE provides a framework for handling data in different MIME types. It is used by Java Mail. XML Processing. Most Java EE components can be deployed with optional XML deployment descriptors, and applications often have to manipulate XML documents. The Java API for XML processing GIXP provides support for parsing documents with SIX and DOM APIs as well as for XSLT. The Streaming API for XML is STX provide a pull parsing API for XML. Json Processing. In Java EE 7, the Java API for Json Processing allows application to parse, generate, transform, and query JSON. Java EE Connector Architecture. Connector allow you to access IaaS from Java EE component. These could be database, mainframes, or enterprise resource planning ERP programs. Security services, Java Authentication and Authorization Services (JAS), enables service to authenticate and enforce access controls upon users. The Java Authorization Services Provider contract for containers defines a contract between Java EE application server and an authorization services provider, allowing custom authorization services provider to be plugged into any Java EE product. Java Authentication Services Provider interface for container define a standard interface by which authentication modules may be integrated with containers so that these modules may establish the authentication identity used by containers. Web services. Java EE provides support for SWAP and RESTful web services. The Java API for XML Web Services JXVS, replacing the Java API for XML-based RPC, provides support for web services using the SWAP HTTP protocol. The Java API for RESTful Web Services JXRS provides support for web services using the REST style. Dependency injection. Since Java EE 5, some resource, data source, GMS factories, persistent unit, EGB can be injected in managed component. Java EE 7 goes further by using CDI as well as the dependency injection for Java specification. Management. Java EE defines API for managing container and server using a special management enterprise bean. The Java Management Extension GMX API is also used to provide some management support. Deployment. The Java EE deployment specifications define a contract between deployment tools and Java EE product to standardize application deployment. Figure 1.2 service provided by containers. Network protocols. As shown in Figure 1.2, components deployed in containers can be invoked through different protocols. For example, a servlet deployed in a web container can be called with HTTP as well as web services with an EGP endpoint deployed in an EGP container. Here is the list of protocols supported by Java EE. HTTP. HTTP is the web protocol and it's ubiquitous in modern applications. The client-side API is defined by the java.net package. In Java SE, the HTTP server-side API is defined by servlet, GSP and GSF interface as well as SWAP and RESTful web services. HTTPS is a combination of HTTP and the Secure Socket Layer SSL protocol. RMI IIOP Remote Method Invocation. RMI allows you to invoke a remote object independently of the underlying protocol. The Java SE native RMI protocol is Java Remote Method Protocol GRMP. RMI IIOP is an extension of RMI used to integrate with CORBA. Java Interface Description Language EDL allows Java EE application component to invoke external CORBA objects using the IIOP protocol. CORBA object can be written in many languages such as Ada, C, C++, COBOL, etc., as well as Java. Packaging. To be deployed in a container, components have first to be packaged in a standard formatted archive. Java SE defines Java archive GAR files, which are used to aggregate many files, Java classes, deployment descriptor, resource, or external libraries into one compressed file based on the zip format. As seen in Figure 1.3, Java EE defines different types of models that have their own packaging format based on these common jar formats. An application client model contains Java classes and other resource files packaged in a jar file. These jar files can be executed in Java SE environment or in an application client container. Like any other archive format, the jar file contains an optional meta-inf directory for meta information describing the archive. The meta-inf manifest.mf file is used to define extension and package related data. If deployed in any ACC, the deployment descriptor can optionally be located at meta-inf/application-client.xml. An EGB module contains one or more session and or more message-driven beans (MDB) packaged in a jar file, often called an EGB jar file. It contains an optional meta-inf/egb-jar.xml deployment descriptor and can be deployed only in an EGB container. A web application module contains servlet, GSP, GSF pages, and web services, as well as any other web-related file, HTML and XHTML pages, cascading style sheet, CSS, JavaScript, images, videos, and so on. Since Java EE6, a web application model can also contain EGB Lite beans, a subset of the EGB API described in Chapter 7. All these artifacts are packaged in a jar file with the .war extension, commonly referred to as a WAR file or web archive. The optional web deployment descriptor is defined in the webinf/web.xml file. If the WAR contains EGB Lite beans, an optional deployment descriptor can be set at web-inf/egb-jar.xml. Java.class files are placed under the webinf/classes directory and dependent jar files in the webinf/lib directory. An enterprise module can contain 0 or more web application modules, 0 or more EGB modules, and other common or external libraries. All this is packaged into an enterprise archive, a jar file with an .ear extension, so that the deployment of these various modules happens simultaneously and coherently. The optional enterprise module deployment descriptor is defined in the meta-inf/application.xml file. The special lib directory is used to share common libraries between the modules. Annotation and deployment descriptors. In programming paradigm, there are two approaches: imperative programming and declarative programming. Imperative programming specifies the algorithm to achieve a goal, what has to be done. Whereas declarative programming specifies how to achieve this goal, how it has to be done. In Java EE, declarative programming is done by using metadata, that is annotation and deployment descriptor. As you have seen in Figure 1.2, components run in a container, and this container gives the component a set of services. Metadata are used to declare and customize these services and associate additional information along with Java classes, interface, constructors, methods, fields, or parameters. Since Java EE5 annotation have been proliferating in the enterprise platform, they decorate your code, Java classes, interface, fields, methods with metadata information. Listening 1.1 shows a POYO, plain old Java object that declares certain behavior using annotation on the class and on an attribute, more an Egp persistent context and annotation in the coming chapters. Listing 1.1 an Egp with annotation. The other manner of declaring metadata is by using deployment descriptor. Deployment descriptor DD refers to an XML configuration file that is deployed with the component in the container. Listing 1.2 shows an Egp deployment descriptor. Like most of the Java EE7 deployment descriptor, it defines the HTTP xml/xml.gcp.org/xml/ns/java EE namespace and contains a version attribute with the version of the specification. Listing 1.2 an Egp deployment descriptor. Deployment descriptor need to be packaged with the component in a special meta-inf or webinf directory to be taken in account. Table 1.1 shows the list of the Java EE deployment descriptor and the related specification. More on that in the coming chapters. Since Java EE5, most deployment descriptors are optional and you can use annotation instead. But you can also use the best of both for your application. The biggest advantage of annotation is that they significantly reduce the amount of code developers need to write. And by using annotation, you can avoid the need for deployment descriptor. On the other hand, the deployment descriptor are external XML files that can be changed without requiring modification to source code and recompilation. If you use both, then the metadata are overridden by the deployment descriptor. This means XML takes precedence over annotation when the application or component is deployed. Note: in today's development, annotation are preferred over deployment descriptor in Java EE. That is because there is a trend to replace a dual language programming Java plus XML with only one Java. This is also true because it is easy to analyze and prototype an application when everything data, method, and metadata with annotation is in one place. Java EE uses the notion of programming by exception. This means convention over configuration, so that most of the common behavior doesn't need to be declared with the metadata. Programming metadata is the exception. The container takes care of the default, which means that with only a small amount of annotation or XML, the container can give you a default set of services with default behavior. Standards. Java EE is based on a standard. These mean that Java EE goes through the standardizing processes of the GCP and is described in a specification. In effect, Java EE is called an umbrella specification because it bundles together a number of other specifications or Java specification requests. You might ask why standards are so important, as some of the most successful Java frameworks are not standardized, Strut, Spring, etc. Throughout history, humans have created a standard to ease communication and exchange. Some notable examples are languages, currency, time, navigation, measurement, tools, railways, electricity, telegraphs, telephone, protocol, and programming language. In the early days of Java, if you were doing any kind of web or enterprise development, you were living in a proprietary world by creating your own framework or locking yourself on a proprietary commercial framework. Then came the days of open source frameworks, which are not always based on open standards. You can use open source and be locked to a single implementation, or use open source that implements standard and be portable. Java EE provide open standards that are implemented by several commercial WebLogic, WebSphere, MQ series, etc. or open source Glassfish, GBoss, Hibernate, OpenGPA, JRC, etc. Frameworks for handling transaction security, stateful component, object persistent, and so on. Today, more than ever in the history of Java EE, your application can be deployed to any compliant application server with very few changes. GCP. The GCP is an open organization created in 1998 by Sun Microsystems that is involved in the definition of future version of an version that is involved in the definition of future version and futures of the Java platform. When the need for standardizing an existing component or APIs is identified, the initiator specification lead creates a GSR and forms a group of experts. This group made of companies, representative organization, university, or private individuals is responsible for the development of the GSR and has to deliver one or more specifications that explain the detail and define the fundamental of the GSR. Java specification request reference implementation RI, which is an actual implementation of the specification, compatibility test kit, technology compatibility kit, or TCK, which is a set of tests every implementation needs to pass before claiming to conform to the specification. Once approved by the executive committee, the specification is released to the community for implementation. Portable. From its creation, the aim of Java EE was to enable the development of an application and its deployment to any application server without changing the code or the configuration files. This was never as easy as it seemed. Specifications don't cover all the details, and implementation end up providing a non-portable solution. That's what happened with JNDI names. For example, if you deployed an EGB to Glassfish, GBoss, or WebLogic, the JNDI name was different because it wasn't part of the specification. So you had to change your code depending on the application server you used. That particular problem, for example, was fixed in Java EE by specifying the syntax for GNDI names. Today, the platform has introduced more portable configuration property than ever, those increasing portability despite having deprecated some API. Java EE applications keep their backward compatibility, letting you migrate your application to newer version of an application server without too many problems. Programming model. Most of the Java EE specification use the same programming model. It usually a POYO, plain old Java object with some metadata annotation or XML into a container. Most of the time, the POYO, plain old Java object, doesn't even implement an interface or extend a superclass. Thanks to the metadata, the container knows which service to apply to these deployed component. In Java EE 7, servlets, GSF, Bacon, Bean, Egp entities, swap, and REST web services are annotated classes with optional XML deployment descriptor. Lesson 1.3 shows GSF Bacon Bean that turns out to be a Java class with a single CDI annotation. Lesson 1.3 a GSF Bacon Bean. Egp also follow the same model as shown in figure in Lesson 1.4. If you need to access an Egp locally, a simple annotated class with no interface is enough. Egp can also be deployed directly in a WAR file without being previously packaged in a jar file. This makes Egp the simplest transactional component that can be used from simple web application to complex enterprise ones. Listing 1.4 stateless Egp. RESTful web services have been making their way into modern applications. Java EE 7 attends to the need of enterprise by improving the GIXRS specification. As shown in Lesson 1.5, RESTful web service is an annotated Java class that respond to HTTP action. More in Chapter 15. Lesson 1.5 RESTful web services. Throughout the chapter of this book, you will come across this kind of code where component only contains business logic and where metadata are represented by annotation for XML to ensure that the container applies the right services. Java Standard Edition 7. It is important to stress that Java EE is a superset of Java SE. This means that all the features of the Java language are available in Java EE as well as in the APIs. Java SE 7 was officially released on July 2011. It was developed under GSR 336 and brought many new features as well as continuing the ease of development introduced by Java SE 5, auto-boxing, annotation, generics, enumeration, etc. And Java SE diagnosing, managing, and monitoring tools, GMX API, simplified execution and of scripting language in the Java virtual machine. Java SE 7 aggregate GSR 334, better known under the name of Project Coin. GSR 292 invoke dynamic or support of dynamic language in the JVM. GSR 203, the new API IO, commonly called Neo 2, and several updates of existing specifications such as GDBC 4.1, JSR 2.2.1. Even if this book doesn't explicitly cover Java SE 7, some of these enhancements will be used throughout the book samples, so I just want to give you a quick overview of what the samples could look like. First, string case. Before, Java SE 7 only numbers, byte, short, int, long, char, or enumeration could be used in switch cases. It is now possible to use a switch on a string compare alphanumerical values. These avoid the long list of if, then, else and make the code more readable. Lesson 1.6 shows you what you can now write in your application. Diamond. Generics arrived with Java SE 5 with the rather verbose syntax. Java SE 7 brought a slightly higher notation called the diamond, which does not repeat the declaration into instantiation of an object. Lesson 1.7 gives an example of declaring generics both with and without the diamond operator. Try with resource. In several Java APIs, closing resources have to be managed manually, usually by call to a close method in finally block. This is the case of resource managed by the operating system such as file, socket, or JDBC connection. Lesson 1.8 shows how it is necessary to put the closing code in a finally block with exception handling, which decreases the readability of the code. The try with resource overcomes these readability problems via a new, simpler syntax. It allows the resource in the try to be automatically released at the end of the block. This notation described in lesson 1.9 can be used for any class that implements a new interface Java lang auto closable. This interface is now implemented by multiple classes such input stream, output stream, jar file, reader, writer, socket, C file, and interfaces such as java.sql.resultSet. Multi-catch exception. Until Java SE 6, the catch block could handle only one type of exception at a time. You therefore had to accumulate several catches to perform a specification action for each type of exception. And as shown in lesson 1.10, you often have to perform the same action for each exception. With Java SE 7, if the handling of each exception is identical, you can add as many exception types as you want, separated by a pipe character as shown in lesson 1.11. Neo 2. If, like many Java developers, you struggle each time you have to read or write a file, Java SE 7 came to your rescue by introducing a new I/O packages, java.neo, with a more expressive syntax. Its goal is to replace the existing Java EO packages to allow a cleaner exception handling, full access to the file system with the new future support of specific operating system attributes, symbolic links, etc. The addition of the notion of the file system and file store, example a partition disk. utility method, move, copy file, read, write, binary or text file, path, directory, etc. Lesson 112 shows you the new Java Neo file path interface. Use it to locate a file or directory in a file system, as well as the utility Java class java.neo.file.files. Use it to get information about the file or to manipulate it. From Java SE 7 onwards, it is recommended to use the new NEO2 even if the old Java EO package has not been deprecated. The code in the lesson 112 gets some information about the source text file, copies it to the destination test.txt file, displays its content and deleted it. Lesson 112, using the new I/O packages. Java EE specification overview. Java EE is an umbrella specification that bundles and integrates others. Today, an application server has to implement 31 specifications in order to be compliant with Java EE 7. And a developer has to know thousands of APIs to make the most of the container. Even if there are many specifications on APIs to know, Java EE 7 focuses on bringing simplicity to the platform by introducing a simple programming model based on POYO, web profile, and pruning some outdated technology. A brief history of Java EE. Figure 1.4 summarizes 14 years of Java EE evolution. Java EE, formerly called G2EE, GTOE 1.2, was first developed by Sun and was released in 1999 as an umbrella specification containing the 10 GSR. At that time, people were talking about Corva, so G2E 1.2 was created with distributed system in mind. Enterprise Java Beans Egp were introduced with the support for remote stateful and stateless service object, and optional support for persistent object entity beans. They were built on a transactional and distributed component model using RMI IIOP, remote method invocation, Internet inter-ORB protocol as the underlying protocol. The web tier had a servlet and Java Server Page (JSP), and GMS was used for sending messages. Figure 1.4 History of G2E Java EE. Starting with Java G2E 1.3, the specification was developed by the Java Community Processes GCP under the GSR 5.8. Support for entity beans was made mandatory, and Egp introduced XML deployment descriptors to store metadata, which was serialized in a file in Egp 1 null. This version addressed the overhead of passing argument by value with the remote interface by introducing local interface and passing argument by reference. G2EE connector architecture GCR was introduced to connect Java EE to ICE. Note: Corba originated about 1988 precisely because enterprise systems were beginning to be distributed. Example Tuxedo and 6 EGPs and then G2E followed on with the same assumption, but 10 years later, by the time G2E was began, Corba was fully backed and at industrial strength, but companies found simpler, more decoupled ways to connect distributed systems like SWAP or REST web services. So Corba became redundant for most enterprise systems. G2E 1.4 GSR 151 included 20 specifications in 2003 and added support for web services. Egp 2.1 allowed session beans to be invoked over SWAP HTTP. A timer service was created to allow Egp to be invoked at designated times or intervals. These versions provided better support for application assembly and deployment, although its supporters predicted a great future for it. Not all of G2EE promise materialized. The system created with it were too complicated, and development time was frequently out of all proportion to the complexity of the user's requirement. G2EE was seen as a heavyweight component model, difficult to test, difficult to deploy, difficult to run. That's when frameworks such as Struts, Spring, or Hibernate emerged and showed a new way of developing an enterprise application. Fortunately, in the second quarter of 2006, Java EE 5 GSR 244 was released and turned out to be a remarkable improvement. It took some inspiration from open source framework by bringing back the POJO programming model. Metadata could be defined with annotation, and XML descriptors became optional. From a developer point of view, AGB3 and the new GPA were more of a quantum leap than an evolution of the platform. Java Server Face JSF was introduced as the standard presentation tier framework, and GIX VS 2.0 replaced GIX RPC as the SWAP Web Services API. In 2009, Java EE6 GSR 3.316 followed the path of ease of development by embracing the concept of annotation, POJO programming, and the configuration by exception mechanisms throughout the platform, including the web tier. It comes with a rich set of innovations such as the brand new GIX-RS 1.1, Bean Validation 1.0, and CDI 1.0. It simplified Matter API like EGB 3.1 and enriched others such as GPA 2.0 or the EGB timer service. But the major themes for Java EE6 were portability through standards in global GNDI naming, for example, deprecation of some specification via pruning, and creating subset of the platform through profiles. Today, Java EE7 brings many new specifications, batch processing, WebSocket, Json processing, as well as improving others. The Java EE7 also improves integration between technology by adopting CDI in most of the specification. In this book, I want to show you this improvement and how much easier and richer Java Java Enterprise Edition has become. Pranin. Java EE was first released in 1999, and ever since, new specifications have been added at each release, as shown previously in Figure 1.4. These became a platform in terms of size, implementation, and adoption. Some features were not well supported or not widely deployed because they were technologically outdated, or other alternatives were made available in the meantime. So the expert group decided to propose the removal of some features through pruning. The pruning process, also known as market for deletion, consists of proposing a list of features for possible removal in the following Java EE release. Note that none of the proposed removal items are actually removed from the current version, but could be in the following one. Java EE 6 proposed the following specification and feature to be pruned, and they indeed disappeared from Java EE 7. Example: Egp2x entity beans CMP was part of GSR 318. The complex of the heavyweight persistent component model of Egp2x entity beans has been replaced by GPA. GIX RPC GSR 101. This was the first attempt to model swap web services as RPC calls. It has now been replaced by the much easier to use and robust GIX-BS. GIXR GSR 93. GIXR is the API dedicated to communicating with the UDDI registry. Because UDDI is not widely used, GIXR has left Java EE and evolves as a separate GSR. Java EE Application Deployment GSR 8.8. GSR 8.8 is a specification that tool developer can use for deployment across application server. This API hasn't gained much vendor support, so it leaves Java EE 7 to evolve as a separate GSR. Java EE 7 specification. The Java EE 7 specification is defined by GSR 342 and contains 31 other specifications. An application server that aims to be Java EE 7 compliant has to implement all these specifications. Table 12 to 16 list them all grouped by technological domain with their version and GSR numbers. Web Profiles 7 specification. Profiles were introduced in Java EE 6. Their main goal is to reduce the size of the platform to suit the developer's needs more efficiently. No matter the size or complexity of Java EE 7 application you develop today, you will deploy it in an application server that offers you APIs and services for 3.1 specification. A major criticism leveled against Java EE was that it was too large. Profiles are designed precisely to address this issue. As shown in Figure 1.5, profiles are a subset of the platform or a superset of it and may overlap with the platform. or with other profiles. Java EE 7 defines a single profile called the web profile. Its aim is to allow developers to create web applications with the appropriate set of technology. Web Profile 7 null is specified in a separate GSR and is for now the only profile of the Java EE 7 platform. Other may be created in the future. You could think of a minimal profile or portal profile. Table 1.8 lists the specifications that are included in the web profile. The CD bookstore application. Throughout the book, you will see a snippet of code dealing with entities, validation constraint, EGB, JSF pages, GMS listener, and swap, or RESTful web services. They all belong to the CD bookstore application. This application is an e-commerce website that allows customers to browse a catalog of books and CDs on sales. Using a shopping cart, customers can add or remove items as they browse the catalog and check out, so they are able to pay and obtain a purchase order. The application has external interaction with the bank system to validate credit card numbers. The use case diagram in Figure 1.6 describes the system actors and functionality. The actors interacting with the system described in Figure 1.6 are employees of the company who need to manage both the catalog of items and customers' details. They can also browse the purchase order. Users who are anonymous persons visiting the website and consulting the catalog of books and CDs. If they want to buy an item, they need to create an account to become customers. Customers who can browse the catalog update their account data and buy items online. The external bank to which the system delegates credit card validation. You can download the code example of this book from the Appress website or straight from the Git repository at https://github.com/agoncal/agoncal-book-java EE7. Summary. When a company develops a Java application and needs to add enterprise features such as transaction management, security, concurrency, or messaging, Java EE is an attractive choice. It is a standard components are deployed to a different container, which gives you many services, and it works with the various protocols. Java EE 7 follows the path of its previous version by adding ease of use to the web tier. This version of the platform is lighter thanks to Pronint Profile and EGP Lite. Easier to use, no need for interface on EGP or annotation on the web tier. Richer, it includes new specification and new features. And more portable, it includes standardized deployment descriptor properties, container, and standard GNDI names. In this chapter, I gave you a very quick overview of Java EE 7. The remaining chapter will be dedicated to a closer study of the Java EE7 specification. Each chapter has several snippets of code and putting it all together sectioned. You will need several tools and frameworks to compile, deploy, run, and test the code. JDK 1.7, Maven 3, JUnit 4, Derby 10.8, and Glassfish version 4. Refer to Appendix A to set up your development environment. Thank you.